Okay. So this is another video in relation to functional blocks. Okay. So the problem set for this one is what if you have a soap dispenser thing. Okay. An item that dispenses soap. Okay. So the item that dispenses soap kind of does only one drop at any given point. Okay. So that's the concern. There's a single drop at any given instance. And then you count the number of times that you dispense soap. So what's the reason why? Because you have a limited supply of soap only. Let's say for this case, to make it more simpler, we only have 5 shots of soap. So napakaliit na container. So tiny, it's laughable. Pero we set it to 5 instead of a larger number to make it easier to simulate. Okay. So what if that would be the case? What do we actually do? Okay. So if that would be the case, what we actually do is we need to enter some things. Okay. The first one is we need to put in an actuator for the motor. Again, as you've seen in the past videos, I prefer to use the motor to be in the output, which is basically pin number 13. Why? Because it's a lot more easier to see compared to the other ones because there's a built-in LED for the system. The 13 motor soap dispenser. So we have a motor that dispenses soap. Okay. So next, we need a level sensor. Okay. Sorry, a position sensor. The proximity sensor that we are using right now, the one that you played around with 2 weeks ago, is probably the same one that we use for this. Okay. So that sensor will now go into input 0 or simply D2, which is the input for proximity sensor. Okay. So essentially, these are the things that you need. Plus, probably we need a start switch. Okay. Start switch, which is now the 3 input. So this is just a way to start the action natin. Okay. So next, we need to start with the uh, flow of information. Okay. So we have the start switch. Okay. We probably need how many? 2 left rails and 1, no, 2 right rails as well, just to be on the safe side. So if I make a mistake, you'll see me getting the outputs detached to this thing. Okay. So the dispensing part is the tricky one because we need to have a short duration only of a signal. Okay. So in this case, we'll utilize the standard block for a TP, a pulse. Okay, we need two of them. So the first one, the first pulse that we get out of it would be initiated by the proximity sensor in the start button. Okay. So, so start, okay, and the proximity. Of course, you need to adjust if your proximity sensor is negated. Kung baliktad siya. Like logic 0 yung kanyang trigger, not logic 1. Okay. So I would need to put in some items here. Okay. Q, we have an additional value for Q here, which is basically something that we need to add in. Okay. Hindi siya timer. This is a internal relay, R1. And this is basically a Boolean value. So the function of this one is to trigger the TP2 or TP1 to fire. Okay. So I think I explained this one in the actual class that this is meant for the initial zero signal and this is meant for the high signal natin. Thereby, we only get a single shot for everything. Okay. So next is we add in our R1 to Q. And we basically bring this one down. Okay. The motor goes to this place. Motor. And the motor is connected to the second point for the right plate. On the left rail, we just basically also place in a value of R1. Ganyan lang siya. And now we have to add in a few items, which is the number of seconds. Again, when you're dealing with time, place T and place hash, and then write down the time in terms of a number followed by S. Now, if you're working with smaller values like those triggering a stepper motor, you use 1 millisecond or 2 milliseconds or 20 milliseconds. Okay. Just consult your driver manual in order to find out the maximum and minimum thresholds. Okay. So let's test this one out. Let's place in start, okay, motor, sensor start, okay, R1. So if the start button is pressed, true siya. Okay. If the sensor or proximity sensor detects a value, did we get a output out of it? So I don't know, hindi ko nakita. Okay, wasn't able to see it properly. So let's adjust this one so that the motor will be rendered as a graph. Okay, the value, there we go. So that's your 1 second pulse for the whole thing. So it only dispenses once. The problem now is how to integrate the number of counts. Okay. For the number of counts, we need another block to be set here. Okay. So we stop the operation and we go into a functional block, which is basically a counter. Okay. So it's up to you whether you want to use count up or count down. In my case, I tend to use count up rather than count down. So what's the reason? The reason being that it's a lot more easier to add stuff than to subtract. So I'm guessing this is the Western mindset. Kasi the Japanese mindset, pag nagbibilang sila when they count, they actually have all the fingers open and then they remove a finger each time that they count. So it's the reverse uh, ideal methodology for it. Okay. So dito siya ngayon sa kabilang side. Okay. So here, we can get a function which is basically our count up, count down value. Okay. So we need to add a block, well, several blocks to be more exact, for the count up, two rails again. But this time, we only have one rail for the right power side. Okay. This rail has to do the disable for the whole system, meaning to say this line, this rung here, should not be able to occur if we have a total count equal to, again, we agreed on this one, a total count of 5. So if the preset value is equal to 5 for the count up, we would trigger another internal relay. So here, we would assign a new internal relay plus relay 2. Triggers to disable TP0. Once TP0 is disabled, TP1 is also disabled. So here we would add R2 and we would terminate it with the right rail. And here we would add the start. So how about the other side of the rung? Okay. So to reset the whole thing, we need the start to be shorted. Okay, meaning to say, negated siya. So this triggers the count of function natin. Sorry. I have a mistake. I forgot to add Mr. Proximity to it. So operating the proximity sensor and the start sensor triggers the counting to happen. Pressing the start or depressing the start allows us a reset action to happen. Okay. So the only thing that we need to do is we need to add in a new switch here, which is basically our R2 switch, which is our kill switch for the TP0. So this disables the whole action of a pulse if and when we exceed the value of 5. Okay. So proximity sensor, toggle value 2. Okay. So in this case, let's go into counter. Uh, let's use current value count. Okay, 0. So it doesn't work because the start button is not pressed. Okay. So when I toggle the value again, I place another one. 2 na siya. Okay. It doesn't work. Bakit? Somebody did not pay attention. This should be negated. Okay. So meaning to say, if this is not triggered, this is allowed. Okay. So let's start the action first. Let's start the action first, and then let's do the operation. So it's slicing edge triggered. Okay. So each time the edge rises for the motor, the proximity sensor, we trigger the system for and last one. So this one will still trigger 5. Anything in excess of 5 should not anymore cause a triggering action to occur. And you can see the current value is stuck to 5. Okay. So basically, in order to let it work, you need to basically reset this one so that your counter output value goes back to 0. So yun na yun. So this is how you can utilize a counter and a pair of timing pulses in order to generate a single pulse to give you or to dispense product into a system, and a counter to monitor the number of product dispensing happening within the system. Okay. So R2 can also be connected to a bell so that you're notified if there's actually something going on dun sa kabilang side. So it can also be a physical uh, item which you trigger. So basically a notification that the soap has run out. Okay. It could also be a light. Okay. Stop. Okay. So that's pretty much this one. Thank you for watching. And again, you would be able to test this one out in the laboratory once we have the session on Saturday.